going to use the information given to write the polynomial function and sketch the graph. A quartic function with a double root at 0 and roots at -3 and 5 contains the point 1, 32. Write the equation in factored form. So using what information we know we have a double root at 0. So that would be x equals 0. We know we have a root at -3, so we would write this factor, x plus 3. And we have a root at 5, so this factor would be x minus 5. And it contains the point 1, so that's our x value, 32, which is our y. Now if we were to write the equation with what we know y would be equal to something. We don't know the stretch, but we do know that this is a double root at 0, so it's going to be x squared because it equals 0. So this is x squared times x plus 3 times x minus 5. So I'm missing the a. So what I need to do over here is just plug in for x and y, 1 and 32, to find out what a is. So y equals the stretch times x squared times x plus 3 times x minus 5. Y is 32. We do not know a. X is 1. And now we just need to simplify and solve. So 32 is equal to a times 1, because 1 squared is 1, times 4 times -4. So 32 is equal to -16a. A is equal to -2. So this is my equation. I plug -2 up into the missing piece here, and here's my answer. Now I need to graph. Well, I know this degree is 4 because it said it was a quartic equation. So the degree is 4. The roots were 0, -3, and 5, and this was a double. I know that because it was given. This is a reflection of an even root, so it's opening down to down. Mark our x-axis to graph and plot our points. Let all of our values be 1 unit away. So this is 0, -3, and 5. This is a graph down to down. I have a double root at 0. So at -3, this is going to go through -3. It's going to come down to 0, but because it's a double root, it's going to bounce and go the other way. And it's going to go back through this point. In the next example, we have a cubic equation, so we know the degree is 3. It's got a double root at -2. It's got a root at 1, and it crosses the point at -1, 6. So what do we know? Well, we know it's a cubic. It's got a double root at -2, so that would be written x plus 2 squared. And it's got a root at +1, and that would be written as x minus 1. What I don't know is a. Substituting -1 in for x and 6 in for y. So 6 is equal to a times 2 minus 1 is 1 squared. -1 plus -1 is -2. So 6 is equal to -2a. A is equal to -3. So this is a degree 3, but it is a reflection. Its movement is up to down. Let's go ahead and graph this function. We have in our graph -2 and 1. So this is a graph going up to down, so it starts here, but -2 is a double root, so it's going to hit the x-axis and shoot back up the other direction, and then it's going to turn for this graph. So this is the way the graph looks. Now I've got one other piece I have to do. Notice the question, write in polynomial form. So that means I need to expand this out to its complete form. I want to multiply the -3 to the x minus 1. -3x plus 3. Now I want to expand x plus 2, and that's going to be x squared plus 4x plus 4. Now I can multiply these two together. So first term to first term, negative 3 times x squared is negative 3x cubed. Negative 3 times 4x is negative 12x squared. Negative 3x times 4 is negative 12x. The next term is 3 times x squared is 3x squared. Let's line that up under the 12. 3 times 4x is positive 12x, and 3 times 4 is positive 12. Let's combine terms. Negative 3x cubed, negative 9x squared plus 12. So our polynomial is y equals negative 3x cubed minus 9x squared plus 12. In the next example, we have a cubic equation with the roots at negative 3, 3, and 1, and the points negative 1 and 8. And this time we have to write the equation in factored form, so we can leave it in parentheses. So we have a cubic equation. The roots are negative 3, so I would rewrite this factor as x plus 3. That would be written as x minus 3 in parentheses, and 1, which would be x minus 1. Okay, write the equation in factored form. So we know we have y equals a x plus 3 times x minus 3 times x minus 1. I'm going to write this twice. This time all I need is to fill in for a. Now everywhere I see an x, I will put negative 1. Everywhere I see a y, I will plug in 8. So we have 8 equals, we do not know a, have negative 1 plus 3, negative 1 minus 3, and negative 1 minus 1. So 8 equals a times 2, this is going to be negative 4, and this is negative 2. So we have 8 equals 16a, so a equals 1/2. So here is the equation that we're looking for. We just need to graph it. This is a degree 3. It's positive, so that means it's opening down to up. That's our movement, down to up. Let's plot our points. So we're starting down. There's no double, triples, or anything, so we're just going to go through these points. Starting down, it's going to cross the y-axis somewhere and turn and come back and cross 3. Somewhere like that. And this is what the graph looks like. In example 4, I have a quartic equation with a triple root at 2 and a root at 4. It's quartic, so we know the degree is 4. And it contains the point 5, so that's going to be for x, and negative 27 for y. We have a triple root at 2. So we would write that as a factor x minus 2 cubed. And we have a single root of just x minus 4. So we have two equations. We have the one that we know all we're missing is the a times x minus 2 cubed times x minus 4. So we have y equals a times x minus 2 cubed times x minus 4. For y, we have negative 27 equals a times 5 minus 2 cubed times 5 minus 4. So negative 27 equals a times 3 cubed times 1. So negative 27 equals 27a. A equals negative 1. It says for the answer, when we need to finish reading it, write in factored form. Well, this is already in factored form, so that's good. This is negative. Its movement is down to down. Plot our points. The roots are at 2 and 4, and we had a triple root at 2. So this went down to down. So we start down, getting ready to go. It's a triple root, so it's going to have that little curve here. But instead of continuing, it's going to bounce and go this way, but it's a triple root, so it's got to bounce one more time, so it goes back up this way. And then at 4, it curves and comes back down this way. So it does have this curvature in here because we're talking triple, cubic. Remember, cubic looks like a snake. Last example. We need to write an equation that passes through the points negative 112, and we got to write it in polynomial form. So we're going to have to multiply all those factors together when we find them. So this problem here is just backwards. We can see the roots are at negative 4, negative 3, and 1. So we have y equals some number a. The roots are at negative 4, so its factor is going to be x plus 4. This root's at minus 3, so its factor is plus 3. This root is at 1, so its factor is minus 1. The x is negative 1, and the y is 12. So let's plug in those numbers. 12 equals a times negative 1 plus 4 times negative 1 plus 3 times negative 1 minus 1. So 12 equals a times 3 times 2 times negative 2. So 12 equals negative 12a, and a equals negative 1. So we have y equals negative 1 times x plus 4 times x plus 3 times x minus 1. But I'm not done yet because I need to multiply through. So the first thing that I would do would multiply negative 1 times x plus 4. Then I would multiply these two together, and then I would multiply the whole thing. So we have negative 1 times x is negative x. Negative 1 times 4 is negative 4. And these two terms multiplied together, we would get x squared plus 2x minus 3. Now I can multiply these two together using distribution. So negative x times x squared is negative x cubed. Negative x times 2x is negative 2x squared. Negative x times negative 3 is positive 3x. Moving on, we get negative 4 times x squared is negative 4x squared. Negative 4 times 2x is negative 8x. Negative 4 times negative 3 is positive 12. Combined terms, we get y equals negative x cubed minus 6x squared minus 5x plus 12.